Okay, so we're going to go over 1.5 and a couple of these square rooty problems. These ones here. There's a couple of them that people have asked for, so I'm just going to kind of go over a couple different ones because I see a couple different themes here. The first thing that you need to know is that the square root of x, I don't know why I'm writing so big. Hold on a second. Let's erase that. Where am I writing? Hold on a second. In the right spot? In the right spot over here? It is in the right spot. Okay. So the first thing that I'm going to show you is remind you that the square root of x is equal to x to the 1/2. Okay. The square root of x is equal to x to the 1/2, and it's going to catch up. Still not caught up. So with that being said, hold on, I'm waiting for it to catch up. There it goes. So the very first thing tells me that, and some of you are like, okay, well, why is that true? Well, that's because this 2 as the denominator really sits right here as the invisible index on that square root, right? So if that's true, how do you write the cube root of x? Well, that would just be x to the 1/3. Does that make sense? That 3 matches with that denominator 3. So that 3 matches with the denominator 3. Okay, so that should help you a lot with 1, 2, 3, 4, and 5. And so I'm going to do a couple. You should pause the video. You should really make sure that you understand it. You understand it, not me, because I already understand it. Okay, so it says use properties of exponents to rewrite expressions. Write your answers in exponential form with positive exponents. Okay, so the very first question I'm going to go through is I'm just going to first rewrite it so that I have no more square roots. So I have no more square roots. I'm going to scoot this off to the side and write right here. Okay, so this one says x to the 2/7. Okay, and to the 2/7 come from, the 2 comes from the squared, right? You should still see this as x squared, right? And then the 7th root of that is the 7th root of that, right? And then I'm going to do the same thing with the other one, which is x to the 3/7. And then the other thing that you have to remember in order to do these types of problems is one of your exponent rules goes like this, right? Like 3 squared times 3 to the 5th equals what, right? 3 squared times 3 to the 5th equals what? So I'm always going to push you back to remembering your definitions. So 3 squared means, oh, there it goes. 3 squared means 3 times 3 times, right? I'm going to make a big dot just so you can see the separation there. 3 to the 5th, which is just 3 times 3 times 3 times 3 times 3, right? So I got a bunch of 3s. So is there, man, I wish there was a better way to write this. There's so many 3s. And you're like, wait, Ms. Johnson, there is. You're right. It's just 3 to the 8th. 7th, sorry, just kidding. 3 to the 7th. And so your brain should be like, oh, I see the pattern, Miss Johnson, I see it. So again, I'm not a huge fan of the rules. Miss Johnson, couldn't you just add the exponents? Yeah, but do you know why you're adding exponents? This is why you're adding the exponents, because there's 2 of them here, 5 of them here. How many of them? 7. So 3 to the 7th is our answer. So you had to remember that you're just adding your exponents when the bases are the same and you're multiplying. So that's exactly what you're going to do over here, right? You're going to keep your base the same. And then you're going to add your exponents. So I'm going to add 2/7 plus 3/7. And that's just going to equal to x to the 5/7. That's it. So the moral of the story here is 2 parts. Number 1, Do you know how to rewrite a square root or a third root, or in this case, a seventh root? If so, good. Awesome. Second part is, do you know how to multiply bases that are raised to a power if the bases are the same? And you're like, yeah, all I do is add them. Good. So those are the two pieces that you needed to know in order to do number one. Now you can do number 1, 2, 3, 4, 5. Okay. There is a little bit of difference here between number 1 and number 2. Notice here, my roots are all different. Here, same root. So same denominator. Oh, I remember this, Miss Johnson. Yeah. So here it's different denominators because we have different roots. So the rules are still going to be the exact same, but do you remember how to add fractions of different denominators? So I'm going to do this one really quick. Then I'm going to skip over a bunch of them just so that you can try them on your own. So the first thing I'm going to do is I'm going to rewrite everybody in the same outside of their radicals. So I get 1/3 times x to the 1/4 times x to the 1/6, right? And now you're like, okay, now what? So then you're like, oh, I remember how to do this. You just told me, just add them together. Yes, we add them together because of this. That's correct. And so if you notice here, we have different denominators. So I'm going to need a common denominator. And if you remember, this is way back in, I don't know, 6th or 7th grade, 5th or 6th grade, ish, 6th grade. So I'm going to look for a common denominator between 3, 4, and 6, right? 3, 4, and 6. So that's a 12. So I'm going to add these and I'm going to put 12 as my denominator. I'm going to make a big fraction with 12 as the denominator, and then I'm going to multiply out. So if it's 1/3, right? So if, in case you're wondering, 1/3 equals to what over 12, right? And you're like, oh, yeah, I remember this. You multiply here by 4. That's correct. So you'd have to multiply the top by 4. Yeah, in reality, you're just multiplying by 1 because 4 divided by 4 is 1. Oh no, it's not catching up to me. Come on. Here it goes. So 1/3 equals to what over 12, right? So you're like, oh, I know how to get there. I can just multiply by 4. Same thing goes here. So then this number is 4. So this number is 4. And then I'd continue all the way through, right? So 1/4 in terms of 12s is 3/12. 1/6 in terms of 12ths is 2/12, right? And then, so then we add our fractions and it's 4 plus 3 plus 2, that's 9/12. So that's x to the 9/12, and I'll just simplify that to x to the 3/4. Okay, so all of this crazy business here gets worked out here, and then you're left with this guy right here, right? Okay, perfect. Okay, so then this one turns out to be the exact same as these guys, that one over there. This one's actually an interesting problem because we know what the square root of 9 is. And because you know what the square root of 9 is, it's a 3, right? And then if you don't know what the cube root of 27 is, you're thinking what times itself gives me 27. So then I just start trying numbers, right? If you don't know your perfect cubes, that's what they're called. So I say 1 times 1 times 1, that's 1. 2 times 2 times 2, that's 8. 3 times 3 is 9 times 3 is 27. Oh, there you go. So the cube root of 27 is 3, Miss Johnson? Yes. The cube root of 3, the cube root of 27 is 3. Same thing goes with this right here. The 5th root of 32, that's actually 2. I can prove it to you. 2 times 2 times 2 times 2 times 2 is 32, right? So then I just multiply this all out. Yes, so 6 times 3 is 18. Okay, so with that being said, you should be able to go through 1 through 5 relatively in the same manner. Okay. This one includes a different rule, so I will write it over here. This rule is when it's something raised to a power. But again, if you just go back to your definition, it works, right? So this 3 right here says I need 3 of those. Like 3 of them? Yeah, 5 squared times 5 squared times 5 squared. That's what cubed means, right? 5 squared times 5 squared times 5. Why did I put 3? Sorry, 5 squared. Yeah. And then now from the earlier one, you know what to do with it. You just add your exponents, or if you want, you can go 5, 5, 5, 5, 5, 5, and you're like, oh, there's 6 of them, 5 to the 6. Very good. So another rule that I'm going to write over here is 5 squared to the 3rd because of what we just did, right? And then you should know the rule, or now the rule should actually make sense to you, right? How did I get that 5 to the 6? Where did that 6 come from? Where did that 6 come from looking at this? And you're like, oh, it's 3 of them. 1, 2, 3. Yeah, you multiplied. So that's why it's a 6, right? Okay. From earlier videos, you should have saw that this negative first actually means it's being divided by. The negative powers means it's being divided by that. So that's what that looks like. This just means 1 over 7 squared. The negative exponents mean divided. And I explained that to you in another video. So go ahead and go watch that video for that one. And it'll help you understand this one, and this one, right? So if exponents are not your jam, like you're confused on them, go watch that. I think there's an exponent video that I made that will make more sense of this. Okay.